Welcome to the deep dive. Today, we're looking at something pretty dramatic, actually. A recent, quite hush-hush meeting of some of the world's top mathematicians and their, well, let's say unexpected run-in with some very advanced AI.
Right.
So our mission here is to unpack what happened when these cutting-edge reasoning LLMs, large language models, went head-to-head with, frankly, the peak of human mathematical thinking.
Yeah.
And maybe more importantly, what this whole encounter tells us about where discovery is heading.
And it's crucial to understand these aren't your everyday chatbots we're talking about.
Oh, no.
The main AI here is a 4 Mini from OpenAI. Its counterpart is Google's Gemini 2.5 Flash. These are specifically built as reasoning models, designed for complex step-by-step deductions. They're lighter, nimbler architectures compared to older LLMs, trained on very specialized data, lots of human reinforcement, which lets them go much deeper into really complex problems than we've seen before.
So let's paint the picture. Berkeley, California, mid-May, this mathematical conclave, as you might call it, 30 world-class mathematicians, some flew in internationally, and they had one goal: come up with math problems that would really challenge this AI.
Basically, yeah, to stump it, if possible.
Or put it through its paces.
Exactly. And tracking a 4 Mini's progress wasn't random. OpenAI worked with Epoch AI, that's a nonprofit that benchmarks these models.
Right, I've heard of them.
They set up the Frontier Math Project, started with a baseline, 300 brand new, unpublished math questions.
Unpublished, key point.
Absolutely key. When they gave these to standard LLMs, even the best ones solved less than 2%.
Wow, less than 2%.
Yeah, it really highlighted the lack of, deep reasoning in those earlier models.
Yeah.
That was the gap a 4 Mini was designed to fill.
Okay, and Epoch AI brought someone in specifically for this.
They did. Ellie Glazer, fresh off his math PhD. He joined in September 2024 to lead this frontier math effort.
Okay.
They set up different tiers of problems, undergraduate level, graduate, then research level challenging.
Getting progressively harder.
Exactly. And here's where it gets interesting. By April 2025, Glazer's tracking showed a 4 Mini could solve roughly 20% of these problems.
20% across those tiers. That's a significant jump in just over 6 months.
It really is. A huge leap. But then came the 4th tier.
Okay, what's that?
These were problems so difficult they challenge even top academic mathematicians, the kind only a handful of people globally could even really wrap their heads around, let alone solve.
Wow, extreme difficulty.
Absolutely. And to keep the test clean, security was intense. Everyone signed NDAs.
Right.
All communication strictly via Signal Messenger.
Why Signal specifically?
To avoid any chance of the AI inadvertently learning from, say, scanned emails or other digital trails, they couldn't risk contaminating the data set.
Makes sense. You need a controlled experiment.
Precisely.
And there was a bit of an incentive, too, wasn't there?
Oh, yeah. A pretty strong one. $7,500 for each problem submitted that a 4 Mini couldn't solve.
Okay. So pitting human ingenuity directly against the AI.
Definitely added a competitive edge. Progress was being made finding these tough questions, but it was maybe a bit slow for Glazer.
So he wanted to speed things up.
Exactly. That's why Epoch AI organized the in-person meeting May 17th and 18th. Get these 30 brilliant minds in a room, split them into groups.
2 intense days.
2 days of intense focus, basically competing to craft problems they knew they could solve, but that they believed would absolutely trip up the AI.
So this setup, this whole confrontation, it must have led to some pretty eye-opening moments.
It certainly did. Moments of, well, genuine shock, actually.
Let's get into one of those. Ken Ono, he's a well-known mathematician at the University of Virginia, and he was a judge there.
Right.
He shared his experience. Said by Saturday night he was getting pretty frustrated because the bot was just too good.
Yeah, it was consistently solving things his group threw at it.
So he decided to up the ante. He gave it what he described as an open question in number theory.
Okay, so we're talking PhD level stuff here, unsolved territory.
Exactly, something experts in his field would recognize instantly.
And this is where things got, well, kind of wild.
Yeah.
Ono described watching the bot work on this problem in real time for 10 minutes.
10 minutes for an open question.
Yeah. And he said he was in stunned silence. First, for about 2 minutes, the AI just found and seemed to absorb all the relevant research papers.
Okay, quick learner.
Then, it actually asked to solve a simpler, related toy problem first. It explicitly said it wanted to do this in order to learn.
It wanted to learn. That's different.
Very different. Then after a few minutes, it just announced, okay, I'm ready for the hard one now.
Did it declare itself ready?
And 5 minutes later, boom, it presents the solution.
Correct.
But Ono described it as sassy.
Sassy? How so?
It finished its proof with a line. No citation necessary because the mystery number was computed by me.
Okay, that is cheeky. Computed by me.
Right. Almost. Self-aware, in a way.
So Ono's reaction, stunned silence, you said. What did he do then?
First thing the next morning, he gets on Signal, tells all the other mathematicians, you won't believe what just happened.
I bet.
And he later admitted, I was not prepared to be contending with an LLM like this. He said, I've never seen that kind of reasoning before in models. That's what a scientist does. That's frightening.
Wow, that's what a scientist does. That hits hard. It wasn't just calculation, it was the process.
Exactly. The learning, the strategy.
Yeah.
It mimicked human scientific inquiry.
So, okay, that's one stunning example. What was the overall result of the meeting? Did they manage to stump it in the end?
They did, yes. Despite a 4-mini's power, the collective brain power in that room eventually found 10 questions that did manage to stymie the bot.
10 problems. So human ingenuity still found the edge. For now.
For now. But the main takeaway for the researchers wasn't just the 10 problems. It was the sheer speed of the AI's progress over just 1 year. They were genuinely astonished.
It really shifted their perspective on the AI, didn't it?
Massively. Ken Ono started talking about working with a 4-mini like having a strong collaborator.
Yeah. A collaborator, not just a tool.
Right. And Yang Hu, he's a mathematician at the London Institute for Mathematical Sciences, already using AI in his work. He went even further.
What did he say?
He said the bot's approach, how it tackled problems, was what a very, very good graduate student would be doing. In fact, more.
More than a very good graduate student. That's quite the statement.
It implies a level of agility, maybe even insight, beyond typical human learning curves in some ways. And then there's the speed factor.
Ah, yes. You mentioned it solved that open question in 10 minutes.
Exactly. Problems that could take a human expert weeks, months maybe. O4Mini does them in minutes. That has huge implications for how fast research could move.
But it's not all positive excitement, is it? There were concerns, too.
Definitely. An alarming side, as some put it, both Ono and Kukov. He mentioned the risk of, well, trusting it too much.
Because it's so confident.
Precisely. Yang Hui, he had this great analogy. He said there's proof by induction, proof by contradiction, and then proof by intimidation.
Proof by intimidation?
I think a 4-mini has mastered proof by intimidation. It says everything with so much confidence.
That's a powerful image. The risk is you just accept its output because it sounds so sure, potentially missing errors.
Exactly. It could lead researchers down the wrong path if they're not extremely careful.
So this capability, this confidence, it must have sparked discussions about the future role of mathematicians themselves.
Absolutely. Big discussions. They started talking about the inevitable Tier 5.
Tier 5. Problems even humans can't solve.
Potentially. Questions so complex they might be beyond current human capacity, if AI gets there.
Then what happens to the human mathematician?
The thinking was the role might shift significantly. Maybe mathematicians become more focused on formulating the right questions, the elegant problems.
And then partnering with the AI.
Kind of. Interacting with these reasoning bots, guiding them, interpreting their outputs. Like a professor leading brilliant, super fast grad students.
Guiding discovery rather than doing all the calculations.
Something like that. It's a potential future model.
So, wrapping this up, Ken Ono had a final thought, a kind of warning.
He did. He really stressed how vital it is to nurture creativity in higher education.
To keep human ingenuity sharp.
Yes, because, as he put it, it's a grave mistake to say that generalized artificial intelligence will never come, that it's just a computer. He believes, in some ways, these large language models are already outperforming most of our best graduate students in the world.
That's a sobering assessment. It's not just a tool anymore.
Not just a tool.
So when we step back from this deep dive, it feels like the real story isn't just AI solving tough math. It's about this emerging ability for, well, something that looks a lot like actual scientific reasoning.
Yeah, the learning, adapting, the strategizing, even the sassiness.
Right.
And that leaves us with a really big question, doesn't it? If an AI can do all that, what does it tell us about intelligence itself? And how is this going to change how we work with machines? Not just in math, but everywhere. What kind of new questions do we need to learn to ask now to keep pushing forward alongside these new kinds of minds?